Good evening. As Rosie said, my name is Jason Scott. My advisor is Dr. Chris Stepanuk. And the title of my project is Preparedness for Oil and Hazardous Material Spills into Lake Champlain. And when I started talking about oil spills in Lake Champlain, most people are like, really? We have spills in Lake Champlain? No. The last major spill in the lake that I could find was in 1963 when the tug William McAllister ran aground on Schillier Reef over on the New York side, and it sunk in 160 feet of water. Divers later went down to the wreck in the early 2000s, and they pulled off the remaining oil, but they think it released as much as 14,000 gallons of diesel fuel. So that was the last large spill that I could find. Now I realize we are not the Port of Houston here. We're not New Jersey. That's why we live here, no offense. But take a look at these photos, right? So this is not what you think of when you think about Lake Champlain. Both of these photos are on Lake Champlain. So this is a Canadian Pacific Railway train on the western side of the lake. And these trains are running from the Midwest over to Montreal and then south to Albany. And they're bringing crude oil in these unit trains. So the unit trains are 100 cars long. Each car is 33,000 gallons of crude oil. And at the peak of their transport in 2017, they were transporting up to 60 million gallons of crude oil a week into the Port of Albany. And then they put it on barges and it goes to refineries in New Jersey. So as you can see from this picture, these trains are running along the side of the lake, sometimes within feet of the lake. If you spend any time over on the New York side, they're very close. There's a lot of river crossings, so there's a lot of risk there. Does anyone recognize this picture over here? Okay, a couple of people. Does anyone know where the world's tallest filing cabinet is? Okay, Switchback Brewing Company. All right, so now we're in the right neighborhood. So this is the global oil terminal. So if you go down the road just past Switchback and right before Oak Ledge Park down here is the oil terminal. And this is a transload facility, so the refined fuel products are coming in via rail, and then they're leaving on trucks to be delivered to local markets, the airport, gas stations, etc. A couple million gallons of storage capacity here at this facility, and this tank right here is within 200 feet of the lake. So I'm just telling you all this to establish that we do have a measurable oil industry and transportation corridor along our lake. So I'm doing a project, not a thesis. I'm still not exactly sure what that means, but I've identified a problem and I've come up with a solution, and I'm currently working on that solution. So the problem is that there's a lack of awareness, education, and resources for an oil or hazardous material spill response in the Lake Champlain region. And my solution, simply, is to work with the Lake Champlain Sea Grant, the Environmental Protection Agency, and the U.S. Coast Guard to increase preparedness for oil and hazardous material spills in our region. And I've got 3 project goals to go along with that. So one is to provide awareness training to marinas and first responders. The second is to create a scientific support network of resources to assist the incident management teams in mitigating the effects of a potential spill or disaster on the lake. And third, to strengthen the existing area contingency plan. And I'll talk about each of these in depth. Part 1 is oil spill training. So the Lake Champlain Sea Grant conducted a survey of all the marinas on the lake in 2017 and found that over 50% of the marinas were in need of some kind of oil spill training. So I worked with the Vermont Boat and Marine Association, and we came up with a curriculum from scratch covering the topics of federal and state regulations, health and safety, hazardous waste management, response tactics, and some hands-on oil spill training. So we came up with this training together, and we actually already completed the training. It was back in May of last year, and we had over 20 participants from Lake Champlain marinas, fire departments, and the Vermont Hazmat team. And all these folks came because they were looking for more information on how to combat spills. We also had National Response Corporation come out, and they're a environmental contractor from the area, from Burlington, and they brought some of their equipment, their vacuum truck and some boom to put in the water to actually show and go through some response tactics for the marinas. The idea with this training is that we've now created the curriculum, we have all the presentations, and we've got some other resources that are going to be posted on the Sea Grant webpage. And so we can either help facilitate future training opportunities, or these individual companies can come in and use these resources to train their own folks. The second part is the scientific support network. This is not a new idea. I'm actually kind of stealing it from University of Rhode Island, and it's a network that I knew of before I came here, but we don't have something like this in Vermont. So I put together a survey. The survey is currently out to over 30 on-scene coordinators from the U.S. Coast Guard, Environmental Protection Agency, and the Vermont and the New York Departments of Environmental Conservation. So it's the leadership folks who are going to be the decision makers in the spill in the lake. And what we're asking them for is to identify specific scientific resources that they would want at their fingertips in the case of a spill or a disaster affecting the lake. The areas that we're looking at are collection and containment strategies, environmental protection, wildlife management, and human health. So once I get all this information back, I'm going to compile the information. I'm going to go out and actually find these resources, namely at the three schools at the bottom, University of Vermont, SUNY Plattsburgh, and Middlebury. And we're going to make a list and catalog a database, essentially, have a spreadsheet of all these resources. So we're going to identify them by name, institution or organization, the areas of expertise, and any special skills or certifications that come along. And this could be for personnel, teams, or equipment. And so the whole idea with this is that we've got a list that's going to be available to the public. It'll be posted on a website, and it will be quickly available to responders. Should there be a spill, they can easily access scientific research that will help them in their decision making for combating a spill. The third part is to improve the Lake Champlain Area Contingency Plan. This is a federally required plan under the National Response System family of plans, as they call it. And so these plans start at the national level, National Contingency Plan for Oil and Hazardous Material Response, goes down to the regional area, and then like our plan here is a sub-area or local plan. So we are a required by federal law plan. The plan for Lake Champlain was promulgated in 2016, mostly in part because of the increase of oil transportation in New York through the rails. So it's a very new plan. And it's a great plan. It meets all the minimum requirements, but it's very short on scientific information. And there's not much information specific to the lake itself. And it is a primary planning tool for federal, state, local, and industry representatives. So it's extremely important to have this plan be robust and accurate. So in working with the EPA, we've identified that it's missing a physical description of the lake. So looking at the hydrography of the lake. So I'm currently doing research and looking at several sections to add to this plan. The first is weather and winds. So looking at seasonal trends in water temperature and wind direction and wind speed. Winds are a really big driver of oil movement on the surface of the water. So it's really important to understand this for responders that are coming to our area. Next, I'll be looking at lake level and inputs. So this is our seasonal river and stream inputs to the lake, including sedimentation and lake level. So as you guys probably know, Lake Champlain can vary by as much as 10 feet or more, depending on the season. And this is really important for responders to understand how this lake level goes up and down and what shoreline areas would be impacted in a spill. There's certain times of the year where there's going to be really sensitive marshes that because of the lake level are now in direct contact with the lake and could be impacted by a spill. And then other times of the year where they're high and dry, and so we don't have to worry about protecting those areas. So this will help responders help prioritize sensitive areas that need to be protected. And lastly, surface currents. So there's not a lot of good information out there on surface currents for the lake. I'm working with Middlebury College right now, and they've got a numerical model of the lake that they've kind of just come up with. They haven't really used it for anything yet, and so they're kind of, we're gonna work together and see if we can, in the model, basically drop oil in a certain spot and see if it will tell us where it will move in certain bays and areas of the lake. And maybe there's some tweaks that they can make to make it more useful. In the coastal ocean environments, we have this readily available through NOAA, but for Lake Champlain, we don't have this information. So that is what I'm doing to increase preparedness for oil spills and hazardous material spills into Lake Champlain. Are there any questions? Yes.
I was curious, so you mentioned oil spills and other hazardous materials spills. So like there hasn't been a big oil spill since the 60s, but are there other like issues, or what would be the main other hazardous material concern?
Mainly rail, and that's kind of why I focused on that. So there's a lot of different, there's stormwater runoff and things like that that can put small amounts of contaminants into the lake. But I'm looking at more large point source, gross pollution incidents. So the rail is a big one. Truck traffic, because all of the rivers, right, that flow into the lake, we have truck traffic going over them on the highways, et cetera. So there is a way for hazardous materials and oil to make it there. There used to be barge traffic on the lake, and I don't see that coming back, but it's a possibility. Yeah. Yes.
I have a question. Is any of this applicable at all to algal blooms?
Absolutely could be. In the scientific support network, I think, is the area where we're going to identify a lot of resources, like the Melosyra, for example, will be listed with the type of instrumentation that it has on board. So I think there's a lot of programs already in place looking at the algal blooms in the lake, but for people coming from out of town maybe to look at maybe like a disaster response, there'll be a lot more information than just what is specific to oil spills.